Okay, let's talk about how to identify functions and relations. We'll start by defining them first, and then we will see how to identify between the two of them. Now we saw how we can write related quantities as ordered pairs earlier. So if you have a set of ordered pairs, and they can look something like this. You have a set, so you have 5, 1, 3, 2, 4, 9, 7, 6. Let's say we have this set of ordered pairs here. When you put these sets of ordered pairs together, you call them a relation. So basically just any set of ordered pairs is a relation. For a formal definition, you can look at this. So if a relation is a set of ordered pairs, what is a function? Think about a function as a special sort of relation, and we can define a function as follows. All right, we are saying by definition that a function is a relation in which for each value of the first component of the ordered pair, that is your x value, there is exactly one value of the second component, that's your y. So for a relation to be a function, you have to satisfy the special requirement here. Your first component, for each value of the first component, you should have exactly one value of the second component, or your y component. So let's go ahead and look at some examples to see what exactly do we mean here. So for your examples, let's look at this set here. 2, 4, 0, 2, 2, 5. Now we are trying to decide if this is a function or is it just a plain and simple relation. Okay? So by definition we said that a function can have only one value of the second component for every value of the first component. Now if you look at this example here, you can look at this ordered pair 2, 4 and 2, 5. For the same x value, you have two different y values, and this does not satisfy our definition for a function. For each value of the first component, you have two different values of the second component. So this here will be just a plain simple relation. This is not a function. Okay? All right, let's see if you can work with this second one. You have negative 3, 1, 4, 1, negative 2, 7. Now looking at each of these three ordered pairs in your set, what do you think? Should this be a relation, or can we classify this as a function? You're trying to see if for the same value of x, do you have two different values of y? If that is true, then you cannot classify that as a function. If for every value of x you have only one value of y, then this is a function, and you can see you don't have a repeating x value in this, so we can classify this set here as a function. All right, let's look at one more example before we move on. You have 9, -2, -3, 5, and you have 9, +2. Now, looking at this set of ordered pairs, can we classify this as a function or a relation? If you look at the ordered pair 9, -2 and 9, +2, you will see again for the same value of x you have two different values for y, and therefore this is not a function. You can classify that as only a relation. All right. Now there's many different forms of the definition for a function you can come across. I just want to give you one more definition for this, so let's look at that. Alright, there you have it. In a function, there is exactly one value of the dependent variable for each value of the independent variable. So this is just an alternative definition to your function. Now there's many different ways you can represent your ordered pairs. You can of course represent it as a set here, or if you want to, you can also show your relationship in this form. Okay, and you have 2 corresponds to 4, 2 corresponds to 5, and then 0 corresponds to 2. We can write another example here. Let's look at that. Let's see, -3, -2, 4, 1 and 7, and you have -3 corresponds to 1, -2 corresponds to 7, and 4 corresponds to 1. Now looking at these two examples, let's go ahead and decide if this is a function or a relation. Now again, remember, for the same value of x, you should have only one value of y. For the same x, you cannot have two different y values. So if you look at our first example here, you can see there are two relationships between the number 2 here. These of course represent your x values, and this one will represent your y. So you have 2 corresponding to 4 and 2 corresponding to 5. So for the same value of x, you have two different values of y, and again, that tells me this cannot be a function. Looking at our second example, what do you think? Is that a function, or it's not a function? Now you have 3 corresponding to 1, -2 corresponds to 7, and 4 corresponds to 1. For the same value of x, you don't have two different values of y. Even though for two different x's you have the same value of y, it's okay. For the same x, you cannot have two different y's, and therefore we can classify this second relationship as a function. All right.